Okay, so what we're going to do on the next, so just kind of find a clean page, and we're going to title your notes today. Let's just call it Chapter 5 Review Lessons 5:1 through 5:3. Okay, all right. So that kind of lets everybody know what we're practicing. Do you go back to, it's not on the quiz, so we're going to come back to that after the quiz. Okay. She was just asking about that stuff with the variables. It's not on the quiz. I checked the quiz yesterday, so we're going to come back to that after the quiz. Okay. All right. What, hon? All right. So the first lesson, lesson 5.1. Oh, come on. Lesson 5.1 was all about, let me make sure that I don't mislead you with titles. Okay. All right. It was all about prime and composite numbers. All right. So that was pretty much the very first thing in this chapter we learned how to do. So in order to be successful in this little section, you must know what a prime number and a composite number are. So who in this crowd can tell me? Olivia, tell me, what is a prime number?
A prime number only has 1 in itself.
Beautiful. As factors, right? So an example of a prime number would be 7. Good. 7 would be a prime number. The only thing I can multiply to get 7 is 7 times 1. What's another prime number? Connor G.
53.
53. That's a prime number. Very good. The only thing I can multiply to get 53 is 1 and 53. Tessa.
11.
11. That's a prime number. What about 2?
2.
2 is prime.
Doesn't matter.
It's the only even number that is prime. All the other even numbers are going to be composite. So that's kind of a quick trick. If you're trying to determine if a number is prime or composite, it's not 2. Look and see if it's even. If it's an even number, boom, you know that thing's composite. So an example, all right? So make this problem number 1 on your study guide, okay? So let's say that I give you a number like 90, okay? I want you to tell me if 90 is prime or composite. This is how it's going to look on your quiz. I'm going to give you a number, and next to it's just going to be a blank line. And on that blank line, you don't even have to write the whole word prime or the whole word composite. You just have to put a P or a C. So, Brody, is 90 prime or composite?
It's composite.
It's composite because what's the definition of composite?
If it has 2 or more numbers other than itself, 3 times 1.
Good. So give me an example of 2 numbers I can multiply to get 90.
45 times 2.
What'd you say?
45 times
45 times 2.
30 times
That would be another one. There's more. What's another one, Brady?
9 times 10.
9 times 10. Good. That's another one. Anybody got another one? What'd you get?
30.
Huh?
Times 3.
30 times 3. Excellent. All of these are factors for 90. So because 90 has multiple factors, it makes it a composite number. Okay? So I want you guys to try these. I'm going to give you just like 4 of them. Okay? All right? So all you're going to do, you're building your study guide. So what I write, you write. All right? Let's do the next one's going to be
Can I do 4 for fun?
Sure. Can you see okay over here? All right, so all I'm asking you to do is tell me if the number that you see is prime or composite. So I'm going to ask Carson. Carson, number 2, prime or composite? That one's composite. Perfect. Number 3, prime or composite? James?
Prime.
Prime. Number 4, prime or composite? Ooh, this one's bigger and people are like, I'm not really sure. Henry? This one not prime. This one's composite. How many got composite? Okay, now, what I want you to learn, Henry, you weren't the only one that made that little mistake. People in 5F made it too. And some other people, raise your hand if you called 111 prime. Look at all these other people who did. So what I want you not to be, all right, pay attention to me, people. Don't be a guesser. What's a guesser? What's a guesser, Max?
Somebody who just like thinks just off the number and just like kind of.
Yeah, beautiful. Don't be a guesser. Guessers, most of the time, don't get it correct. Okay? If you get to a number and that number is difficult, no. And that number looks big and it looks a little harder and you're like, I don't know if it's prime or composite, then guess what? You gotta put a little work in. Up here. You don't just guess. You gotta put some work in. And so the work that I wanna see you put in is what? What, Addison?
Like hard work, like
Using what? What can you use? The work.
division,
You can use.
or you can use your divisibility rules.
Very good. Use those divisibility rules for help. Remember, if the number works for only one of the numbers in the divisibility chart, then it's going to definitely be a composite number. So tell me, is this number 111 going to work for 2?
No.
No, because 2 says it has to be an even number, and 111, as we know, is not even. Brendan, what you doing?
I'm writing a comment to this week.
Okay, well, that's not what, I appreciate your honesty, but that's not what we're doing right now. Okay, you're missing out on this. So, 111, will it work for 3? Yes.
It will, because if you add up all the numbers, like
Excellent.
it's divisible by 3.
Yes, she's using her brain. She's using what she's been taught. She's been taught that if the number looks too big, don't just guess. Use your tools. In her brain, she's got tools that have taught her the divisibility rules. So if I add up 1 plus 1 plus 1, I get 3. Will 3 be divided by 3? Yes. So 111 can be divided by 3. So now, because it worked for one of those numbers on the chart, I know that it's a composite number, okay? Don't be a guesser. There will be some numbers
3 times.
on your quiz, you guys, that are big, like that one. But I don't want you just guessing, because when you guess, you got a 50% chance on getting it right and a 50% chance on getting it wrong. If you use your tools, you'll have a 100% chance on getting it right, okay? All right, so that was like the first section that we did. Y'all feel pretty good with that section? Okay, all right, so let's move on to the next section. We're still in 5-1, okay? We haven't left this section yet. But now we went into this stuff called prime factorization. And this is when we learned how to use factor trees. Okay, and some of you all really enjoyed these. All right, so let's try a factor tree. For a factor tree, we start with a composite number. Is there ever going to be a composite tree?
No.
No. Composite trees don't exist because the job of the trees are to figure out what are all the small numbers that make up that big number. So we're going to start with a big number at the top. Let's start with 28 at the top. That's our composite number. That's the star of our tree. Mace, come on. I need to see motivation. You're not writing when I'm writing. All right, now, Mason, walk me through how to build this tree, okay? What am I going to do? Since 28 is composite, what do I have to do? Come on, use your words. You got to tell me where 28 came from. 28 came from 2 numbers that got multiplied together and made 28. So what 2 numbers can I multiply together to get 28? I need to hear something. Huh?
I don't know.
Well, I'll give you one number. 4. 4 times what's going to give you 28? Not 8, but you're close.
7.
7. 4 and 7 give me 28, okay? I'm not leaving you. You have to finish this tree, okay? So 4 times 7 is what's going to give me 28. Think of it like a family tree, Mason. Up here at the top is you. Where did you come from? You came from a mom and a dad, right? So where did 28 came from? It came from a 4 being multiplied by a 7. So now we have to ask ourselves, since we know all this prime and composite stuff, we have to ask ourselves, is 4 or 7 prime? Are either one of those numbers prime numbers? Mason, what would you say? Are either one of them prime? Which one?
7.
The 7 is. So 7 gets to turn into an ornament on my tree. The only ornaments on my tree are going to be prime numbers. All the other things are not ornaments. They're just decorations. Okay? But since 4 is not prime, Mason, now I have to say where 4 came from. So what two numbers multiplied together to get 4? 2 and 2. Should I ever put a 1 on my tree, you guys? No. Because the purpose of the tree is to get numbers smaller and smaller and smaller. If I put a 1 on the tree, is it going to change anything? It's just going to keep the numbers the same, okay? So now I've got a 2 and a 2. Mason, are those guys prime? They are, so they can get turned into ornaments also. And now I'm done. I've done all the numbers that I need. So I've got 3 ornaments on my tree. Now it's time to put these ornaments into a factorization, okay? So I'm going to start with my smallest ornament. Mason, what number ornament is the smallest? 2. So the 2 is going to get listed first. And how many 2s, Mason, do I have on the tree? So that's why my exponent becomes a 2. 2 to the second power, okay? I'm going to multiply that by the other ornaments on my tree. What's the only other ornament on the tree? 7. And now I am finished. So my final answer is 2 to the second power times 7. That's how I do prime factorization using factor trees. So, did y'all get that pretty easily?
Yeah.
Okay, so why don't you all try some, okay? So now that we've kind of walked through that one, let's practice. Here's number 5 on your study guide, okay? Factor out, let's do, I don't know, 48. Do 48.
Didn't we do this like yesterday?
We did? All right, then let me give you another one. I don't know. I
No,
know.
I wrote down 36.
Let's do 72. How about that one?
This one has so many factors, so you can do it.
Yeah.
That's right. Remember, it does not matter what 2 numbers you start with from the top. You got to start with 2 numbers that tell me what 2 numbers multiplied together to get 72. Whatever 2 numbers you pick is fine, as long as they do get 72. Yeah, I'm ready.
This is the number I got from after you yesterday.
Oh, it was. Oh, shoot, sorry.
We also did the same thing.
I remember this.
In this- Sorry.
It's
Weird, my brain uses the same numbers all the time.
My choice is
Yes, ma'am.
outside. What, does it have to, do you have to have a prime number in it or not?
In what, buddy?
Like when you're doing the factor trees.
Yes, the factor trees, the reason why it's called prime factorization is because your ornament should always be the prime number. So, okay? You never stop until you have found all the prime numbers. Okay? You already know it, Mason? Okay.
I already have it.
All right, so Mason W this time. Tell me, what 2 numbers did you choose from the start?
8 and 9.
8 and 9. Who was like Mason and chose 8 and 9? All right, we had a lot of people who chose your numbers. Did anybody choose 2 other numbers to start with? What did you choose, Brennan?
36 and 2.
36 and 2. Is that what you guys chose? So is that what you chose?
No,
What did you choose?
12 and 6.
12 and 6. What did you choose? Connor, did you choose one of those?
Yeah, I chose 12 and 6 also.
Okay, so even though we started different, your all's trees may look a little bit different along the way, but all the ornaments will be the same, okay? So just check to make sure that our ornaments are matching. So Mason, are 8 or 9 prime?
9 and
Nah.
No.
No, it's not. Not 9. What numbers will give you 9?
3 times 3.
There you go. But 9 is very common for people to mess up on. Everybody sees 9, it sees it at odd, and they're like, that's a composite number. Don't make that mistake. It's not composite. It's not, I'm sorry, prime. Not prime. It's a composite number. So now you gotta tell me, buddy, where each one of these guys came from. Where did 8 come from?
4 and 2.
It did. It came from 4 and 2. So let's do this side of the tree first. Are either of those prime?
Well, 2 is.
2 is. So I'm gonna turn 2 into an ornament. Okay? Mason, keep going. What about 4?
2 and 2.
Perfect. Are either of those prime?
Yes.
Yes. 2 is always prime. It's the only even number that's prime. Okay? All right, now let's move to the other side of the tree because this side is completely done. We don't have anything left hanging at the bottom. All right, 9. Since 9 is not prime, tell me where 9 came from.
3 and 3.
Came from 3 and 3. Oops, that's a bad looking 3. Are either one of those prime?
Yes.
Yes, they are. That's okay. So we're going to turn both of those guys into ornaments. So that side's now done. So those of you that started with 2 different numbers, do you have the same ornaments I got?
Yes.
Okay. So now, Mason, we have to turn this thing into something that looks like that, with it, like how we use it with exponents. So let's start with the smallest ornament we have on the tree. What's the smallest ornament we have? We have a 2. How many 2s do we have? We have 3 of them. So that's why our exponent is going to be a 3. We're going to multiply that by the next ornament. What's the next ornament? And how many of those do we have? So our power is going to be 2. Your final answer should be 2 to the 3rd power times 3 to the 2nd power. How many people got that?
I got
Brody, did you get that? Let me check out what you got. Let me see. So your trees look good, okay? So only thing that happens here was your exponents. You had a 2. How many 2s are on the tree? So that's why that exponent should be a 3. And then how many is that 8? So then that one should have 2. Okay. All right. So how do y'all feel with factor trees? Good? Yes.
So I knew everything correct except that I didn't put on 8. I actually did more than 4, even though I know it's 4 times 2.
Oh, yeah. And that happens. So that's a common mistake that she made. She said, I accidentally, when I got to 8, I did 4 and 4. Because her brain was thinking addition. Okay? And when those things happen, it throws everything off. So just be careful that you don't accidentally add in the middle of a factor tree. Remember, factors are multiplication. Brennan, something go wrong?
I figured mine
You figured it out?
Yeah.
Was yours the same thing, kind of like her?
out. No.
It was just maybe like a multiplication issue?
Well, yeah, actually kind of was.
Okay, all right. Well, as long as you find your mistakes, then you probably won't make those mistakes down the road. Okay, so y'all, that was lesson 5.1. How do you feel in lesson 5.1? Good. Okay, let's move on to lesson 5.2 then, okay? All right, so lesson 5-2, this was on common factors and GCF. What's GCF, everybody?
Greatest common factor.
Good, beautiful, okay? So remember, I cannot find common factors if I'm not comparing 2 things, right? Like if I brought Rory up here and I was like, okay, we're gonna compare Rory. All right, Rory, stand here, all right? I want y'all compare Rory to me. And I didn't say anything else. Could you compare her?
No.
I have to have something. You would have to have something else to compare her to, right?
Yeah.
So when you're comparing things, you have to have at least 2 of those things to compare. If I had Rory up here with Allie, then we could start comparing things, right? So if we're playing in the land of numbers, if we're comparing things or finding things that they have in common, we have to have at least 2 of them in order to do it, okay? So, I don't know, what number is it? 6 of our study guide? Okay, so let's compare numbers 10 and 12. Okay? All right, so the first thing that we have to do when we are finding common factors is we might have to list the factors of each number. If the directions ask us to do that, then that's what we got to do, okay? And on your quiz, there is a section where it says list the common factors. So here's what it wants you to do. It wants you to look at each number and tell me what are all the factors for each of those numbers, okay? So tell me, what are the factors for 10? Emily, I'm trying to figure out what numbers I can multiply together to get 10. Do what? Okay, so rather than just kind of like thinking in the air, let's come over here and show what our brain is thinking. Start with the easiest one. What's the easiest one that we know will work for 10? Times. So 1 times 10 is obviously the easiest, right? What's going to be the next one? Because we're going to go in order. Now, these seem easy because they're small numbers, but yesterday in Nathania, I gave them a large number. And I said, list the factors for this number. And when they were standing up here trying to list the factors, they started staring up at the sky because they were trying to think of what all the factors are. But rather than do that, I told them, write out the factors. Most of us, our brains learn better when they see it. So let's write it out to help our brain out. So 1 times 10 will give me 10. The next number I would come to would be 2. Is 2 times anything 10? Good. 2 times 5 is 10. What about 3? Is 3 times anything? 4?
No.
And we've already got 5, so those are all of our factors. Okay? So let's come over here, Emily, and now list these factors in order from the smallest one to the largest one. What are they? 1. List the factors. 1. I can't hear you. 1, 2, then 5, and then 10. So these are my factors for 10. Y'all see how I made those? Okay, let's do 12's factors. Okay. All right, Sophia, do 12's factors.
Okay, so first is 1 times 12,
Uh-huh.
2 times 6, or 2 times
Yep.
6, 3 times 4.
Okay.
And then the factors are 1, 2, 3, 4, 6, and 12.
Thank you. This is 1, 2, 3, 4, 6, and 12. All right, perfect. Okay. Now, do you notice how without writing it all out like I just did over here, you may miss some of the factors? Because some of you are just trying to think up in the air. You're trying to think through, like looking inside your brain, what all the numbers are that'll give you 12. And sometimes that's a little harder. Writing it out, make sure you don't miss things. Okay. So now if we're trying to find the common factors, because that was the first thing that we learned in this lesson. What numbers do 10 and 12, Sophia, this is your problem, have in common?
Okay, so in common they have 1 and 2. And then GCF is 2.
So they have 1 and 2. Those are the common factors. So if it asks me to list the common factors, these are the numbers I want to see. Because those are the 2 numbers that 10 and 12 have in common, right? Even though they have those others as factors, those aren't common factors, right? Now, I want to take this and I want you to tell me what's the greatest common factor. And that's just going to be the largest one that they have in common. So the GCF is 2, all right? And that's basically what lesson 5.2 was about. So I want you all to try one of those, okay? So that was my example for your help. Let's do, I'm going to pull one from the book. And I'm going to give you numbers that might be a little more challenging, okay? It's because I want to see if you get all the factors. All right, what number is this, 7?
7.
Okay. 18 and 36. Those are your numbers. I want you to find the common factors and then find the greatest common factor.
I know the greatest one.
But I'm asking you to find all the common factors. So even though you already know the greatest one, that's great. But you still gotta find the common ones too.
On 36, do we only list 6 once?
Yes, yes. I mean, if you listed it twice, it wouldn't be a big deal, but you don't have to. Don't worry, honey, your lunch count, I think, came in late. You're gonna probably have to take it downstairs. And I love how some of you are really thinking, but remember, don't just use the sky as your place to think. Use your paper as a place to think. Write those facts out. Go in order. Number 1, number 2, number 3. And just walk yourself through it to make sure you don't miss any factors. Okay, I know some of you might still be trying to kind of create your answer, but just because time is kind of a problem for us, we want to go ahead and kind of work through this. So Addison, we can look at this problem right away and know what our greatest common factor is, don't we?
Mhm.
How do we know that so easily, so quickly?
Because 18 can go into 36 easily, and if it can do that, you have your greatest common factor.
Excellent. So in case you didn't hear what she said, because I know these maths sometimes kind of like muffle our voices, but she said right away, and I know there was a lot of you in here who saw it too, 18 will fit into 36 perfectly. So instantly, she and a lot of other classmates identified that the greatest common factor is 18, okay? But if all we had to find was the greatest common factor, then we would be done with that problem. But we're not. It's asking us to list the common factors too. So this takes a little more time. So Addison, tell us the factors for 18.
1, 2, 3, 6, 9, and 18.
Beautiful. She didn't miss any. She's got them all. All right, let's do 36. Now this is her problem, y'all. Hang on. All right, Addison, 36. Give it to me.
1, 2, 3, 4, 6, 9, 12, 18, and 36.
Excellent. Very good. That's a lot, right?
That's a lot of that.
So now I have to figure out which ones do they have in common. And that's gonna give me my common factor. So I'm gonna just circle the ones you tell me they have in common. So Addison, which ones are common?
1, 2, 3, 6, 9, and 18.
And do you see how since 18, all of those numbers have circles on them? That's why 18 is the largest one they have in common. Because they have all those in common, but the largest one is 18. So our GCF that we had at the beginning was right, but the common factors, if I list them out, would go 1, 2, 3, 6, 9, 18. That's the answer I'm searching for on your test. So the sections that ask you to find the common factors, I want you to do this stuff, okay? Do I need to see all of this on your test? No, that's what's on your work page. What I want to see on the test is that. That's the answer. Okay, that's the answer, greatest common factor. The other stuff is your work. It's the work that helped you get to your answer, all right? That's 5-2. Good?
Yes.
Okay.
Hello, you know that we had for a double class, right?
No, what? Yeah.
I was trying to tell you that whole class was like, oh, that's why I raised my hand in the first place.
Okay.
Okay, good for time.
We, back to back, so she was basically telling me I don't have to rush.
Yeah.
But I don't wanna make y'all have to stay in math for longer than you probably want to. But, that's good, so now I don't feel as pressure.
Yay.
Okay, now, so we have one last lesson, and then we're gonna wrap this thing up, and you're gonna be ready for tomorrow's quiz, okay? So, the last section was section 5-3. This is the one that we had a little review on yesterday. It was also the one that at the end of the day yesterday, when we were playing with those variables, I said we would come back to it. But I looked at your quiz, and your quiz doesn't have any of that on it.
Oh, I was like, thank goodness.
So, we are gonna just come back to that after we take the quiz. We're only gonna focus on what's gonna be on the quiz for tomorrow, okay? So, the first thing in lesson 5-3 that we really learned to do was estimate fractions,
Oh, these are like.
okay? And it was asking you to estimate and tell if the fraction was closest to 0, 1/2, or 1/2. Okay? That was your job. Was to try to figure out if the fraction that they gave you is closest to a 0 on a number line, closer to a 1/2, or closer to 1/2. Okay? So if we look at an example, so this is now problem number 8. Okay? If we look at an example would be something like 2/11. Okay. So I'm gonna go with Connor. Let's hear it. All right, Connor. When we learned how to estimate fractions, we learned there was a couple of tricks that we could use. Okay. If the number on the top, which everybody, what do we call the number on the top of a fraction? Numerator. If the numerator was really far away from the denominator, then which of those numbers up there would it really be closest to, Connor? 0. Okay. If the number on top, which is the numerator, is about half of the number below it, then it would be closest to what? 1/2. If the number on the top, which is the numerator, is just about the same as the number below it, then it would be closest to 1. So now that we know all that information, Connor, is 2/11 closest to a 0, a 1/2, or a whole? 0. It's closer to 0. Good, Connor. Okay, you all try some of these. Ready? These puppies are pretty simple. Oopsies.
I think you have to write them in the answer.
I know. Let's see.
8. I'm doing these as you're writing them down. Me too. A lot of kids problems. Well, I didn't remember that. I can't copy from that.
This is the one time in our lessons where the estimating is the easy stuff.
Yes, I know, yes.
Normally, estimating is something that we despise, we hate it.
I hope everybody wants to do different things.
But this is
Nobody
fun.
else can do
All right.
that.
So Brady, let's do this. Brady, 7/8 is closest to what?
1.
It is. It's closest to 1. Brady, 6/11 is closest to
1/2.
1/2. Good. Because 6 is about half of what 11 is. If 11 was 12, then 6 would be a half of that, right? What about 2/12, Brady?
0.
That's another 0. Okay, how do you do? Hang on, please, what?
I don't know if you already said this, but my mom taught me to like instead of like to round it to like I just remember you round it 11 to 10 to 6 is high. So my mom taught me.
This one you said?
You round 11, 10, and 6 is high.
You could, just another way to solve it. I don't know. Okay, so we have one thing left because after we learned how to estimate fractions, we then learned how to make equivalent ones. Okay, so after that section came this equivalent fraction stuff. So this is where we learned how to make equivalent fractions with multiplication or division. Okay? We really use the multiplication when our fractions are starting out kind of small, right? The division we use when the numbers we're playing with are pretty large.
How many are we gonna do? 30?
Yeah. Okay, so for the first example that I'm going to kind of do with you, let's use, we're going to use multiplication for these, okay? So it's just easiest if we just start and do one together. So for number 12, our fraction is going to be 5/8. And I want you to give me 3 fractions that would be equal to 5/8. So how did we learn how to do this? Dominic, how did we learn how to do this?
Well, we took 5 and we take the 5 and then we multiply it by any number below 10. Well, you can go above 10, but it's too complicated.
Yeah.
To do that. And you multiply 5 and 8 by 2.
Okay, you
I'm
want,
saying my number is 2.
okay,
And then the number you get is the equivalent fraction to
Yes.
that fraction that you just multiplied.
you could be the teacher, Dominic, perfect. So Dominic, you said you wanted to choose a 2, you said?
Yeah.
Okay, so he's gonna multiply his numerator and his denominator by a 2. So what are you gonna get when you do that, buddy?
So we're probably going to get 10.
You are?
And then for 8, you're going to get 16.
Beautiful, okay? Now, what do you wanna do next, bud?
10 times 3.
All right, he wants to now take the new fraction he just made and multiply them each now by 3, he said, okay? All right, well, when you do that, what are you gonna get?
Well, 10, you're going to get 30.
Okay,
And then for
we'll work that thing out.
you're going to get 48.
Excellent, very good, okay? So now our fractions are starting to get kind of big, right? So instead of like using the new one we just made, let's go back to the one that we started with. 5/8 is the smallest one. And let's just pick a number that's not 2 and not 3. 6, okay, all right. So what are we gonna get when we multiply them each by a 6?
Well, for 5, you're going to get a 30. And then for 8,
Then we get same thing. But you know why? Because to get this 10, you multiply things by a 2, and to get this 30, you multiply things by 3. And 2 times 3 is 6. So that's why when you tried to pick 6, it already gave us the one we got. So pick a one that isn't using any of that stuff yet. 7. All right. I know that's going to give me a new one. Okay. All right.
anyways, you can go back.
All right. So, oh yeah, you can. Yeah. So tell me what I would get if I multiplied each by 7.
You get 35 from 5 and then 56 from 8.
Excellent. Very good. There we go. 3 equivalent fractions. Okay.
We're done.
So how y'all feel with that? All right. Let's do one with division. Not Okay. Hang on 1 second, girl. Yes. Oh, for sure. Yeah. Yeah. So you don't have to pick a new number. So listen, she asked a great question. I know you all are, listen, this class only was really ending 3 minutes or 2 minutes ago, so don't get too wiggly and antsy yet. But Allie just asked an excellent question, and her question was, can I just keep the same number and use the same number the whole time? Sure. So like she started with a 2, and she got 10 over 16. She kept that 2, and then got what?
I got 20 over 32.
Excellent. And then kept that 2 again, and got what?
I got 40 over 63.
Yes, absolutely. All right, let's do one with division, okay? So, what if I gave you one that was, 7 over 21. Okay, I want you to use division and give, I just want one.
Oh, one?
Just one. Use division and give me a fraction that would be equal to 7 over 21. Now remember, to do this, you have to know what the greatest common factor is between 7 and 21.
Oh, is it 7 prime?
But 21's not.
All right, yeah.
And remember, the trick in finding the greatest common factor is asking yourself, will the numerator go perfectly into the denominator? If it will, then boom, you know what the greatest common factor is. Max, honey, sit. All right, Cassidy wants to do this one. So Cassidy, what's the greatest common factor between 7 and 21? 7 is. So she's going to now divide her numerator and her denominator by that 7. And what are you going to get when you do? 1 over 3. That's also called simplest form. So when we get to the point where you're putting a fraction in simplest form, that's what Cassidy just did there. She turned 7/21s into simplest form, okay? I'm gonna give you all 2 more to practice and then we will call it a day, okay? This one that I'm gonna give you is gonna be 15 over 25, okay? And then the last one, division, yes sir. And then the last one is going to be 12 over 46. And remember, when you're using division, you gotta find the greatest common factor first. So that recipe for solving this stuff, first, find the greatest common factor. 2, divide numerator and denominator by it. What's going on?
I don't know.
All right, well, that's okay. So let's look here, James. I appreciate you kind of speaking up. Because you are the only one.
Yeah.
All right, so,
I can give 15
all right, well, wait a minute. So if you're stuck on finding the greatest common factor, go back to that lesson that we learned how to find the greatest common factor. I know you're trying to help each other. But if you're stuck on finding the greatest common factor, then in lesson 5.2, we just learned how to find it. So what are the factors, James, for 15? If 15's
No, I'm having trouble on number 15.
Oh, my fault. Okay, what are the factors for 12?
There are 1, 2.
Well, okay.
Toss it.
One, 2. All right, keep going. 3, 4.
6 and 12.
6 and 12. Excellent. Okay, those are 12. That's the factors for 12. So the factors for 46. 46 isn't a number that we see a whole lot, is it? So he's trying to figure out, what do they have in common? So 1 and 46 we know, right? It's an even number, so we know that 2 and something is gonna give me 46.
It is 23.
So if you're not sure, you can come over here and do 2 divided by 46. And when you do, you see that 23 is your missing number, okay? All right, let's keep going. Is 3 times anything 46? Think of your divisibility rules, bud. Add 4 and 6 together.
No.
You get 10. 3 times anything?
No.
That's not gonna work. What about 4? 4 times anything?
No, because 23 won't.
We're not sure. We can do some division, okay? Just to make sure that we don't have a goof up. Will 4 go into 6 perfectly?
No.
No, so 4 won't work. 5,
No, because it doesn't have those 5 or 0
Right.
in one's place.
6. Remember, 6 rule. What's 6 rule?
If it works for delivery.
It won't work because it doesn't work for free.
Good. So 7. Is 7 times anything 46?
No.
8,
No.
9,
No.
10,
No.
11,
No.
12.
No.
Are you sure?
No, because 12 times 4 is 42.
Okay. 13.
No.
No. So do we have all the factors?
Yes.
So what do we think the greatest common factor is?
2.
So if we divide each by 2, what are we gonna get? So James, we'll just let you finish that problem out. What did I do with mine?
Okay, I'm done.
It's over there.
Oh, thank you. All right, so James, it took a little work on that one, but we did discover that 2 was the greatest common factor between each of those. 12 divided by 2 is? James?
That would be 6.
6. 46 divided by 2 is?
23.
23. And notice, you all, come over here and look at our factors. Okay? So listen, please, look at our factors. Our factors here are helping us to know, like, when we got, the 2 is the common factor, and the 23 is the denominator. See that? So we really kind of, in our work, we figured out what the missing number was down here. We didn't have to do that math all over again. What about 15 and 25? Shane, what's the common denominator between 15 and 25? Or sorry, the greatest common factor. 5. So if I divide each by a 5, Shane, what's my new fraction gonna be? 3 over 5. That's all you're gonna have on your test. So, or quiz on the test. Brandon has a question? All right. Hey, in a second. So, tomorrow, quiz. Now let me tell y'all one little last thing. Your quiz tomorrow, it has a total of 35 questions. But that shouldn't be something that makes you go, oh my gosh, that's so many. Because think back to the first thing we did. First thing we did was prime and composite numbers. The first 8 questions are asking you to put a P or a C on the line. And so even though it seems like a lot, these are questions that you can answer really quickly, okay? All right, let me check and see. I don't know if there's people in the bathroom, so we may have to wait.